Okay, in a hydrogen atom, which electronic transition would result in the emission of a photon having the shortest wavelength and which would have the largest frequency? Put these in order of largest energy, either absorbed or emitted, to the smallest energy. So that's what we're going to do in the end. So wavelength, frequency, and then energy. So all of these can be related to each other using the equation that the energy is equal to hc over lambda, but it's also equal to h times the frequency. So this is our wavelength, frequency, speed of light, and Planck's constant. And this, of course, is our energy. So this is asking us to find a photon, an emission of a photon. And so we want to find stuff that's going to be an emission. When we go from so let's just kind of write what each of these are on our little list here. Let's call this n equals 1. This would be 2, 3, 4, 5, and 6. Now, you notice that they get closer and closer together the further out we go. That is because it's actually, now this isn't actually to scale, but it's trying to give you kind of the idea that there's more energy to go from 1 to 2 than it takes to go from 2 all the way to infinity, it turns out. And then it's more energy to go from 2 to 3 than from 3 to infinity, and so forth. So they get closer and closer together as they go. So the largest transition is actually between 1 and 2. So we have the first one, we have an electron going from, so A here, going from n equals 1 to n equals 3, okay? And that transition from here to here is going to be an absorption, okay? Because it's going to excite that electron up there. Second transition is from 3 to 2. So we start at 3, so this is B. Put a thing around A as well. So this is B. B is going to start at 3 and it's goes down to 2, right? So, and that is an emission. That will, since it's going from a higher energy level to a lower energy level, it will emit a photon. So there's one we want to look at. The next one is from 3 to 4. So we're going from here, this is C, goes from here up to here, okay? And that is going to be an absorption, so we're not worried about that one. Next one, D, goes from 5 to 3. So we start all the way up here at 5. I'm not even going to do the arrow, but we're starting at 5, and we're going all the way down to 3. 1, 2, and to 3, right? So this is our D, and that is going to be an emission. So, so far we've got B and D are emissions. Really, all we have to do is look at these numbers. Go from 10 down to 5. Well, 10 isn't even on here. The 10 is going to be somewhere up in this region here. And it goes down to 5. Oops, I went past it. So let's forget that. From here to there. Not even quite that long, but that would be E. And that's also an emission. Okay, and the last one, from 3 to 1. So we start here and go all the way down to there. And that would be an emission as well. This one is F. Okay, so which of the electron transitions would result in the emission of a photon having the shortest wavelength? Well, shortest wavelength means highest energy, right? And I have this picture here because it kind of helps me get the idea on whether it's going to be greater or less energy. And I can just do this sort of by looking at it, by inspection, rather than actually doing calculations. I could do the calculations for each of these, but that would take a lot of time. And all I need to do is actually order these in highest to lowest energy. So let's look at B, D, E, and F. From B, we go from 3 to 2. So we're just going this distance here. It looks like that. And that's much shorter than this one here from 3 all the way to 1. That's a long distance. So this F here is by far the largest emission that we have. So F is the largest. Is the largest energy, right? So the largest energy then is going to give us the smallest wavelength. So this is going to be the smallest wavelength. F has the shortest lambda, okay, because it has the largest energy. Now, which one has the largest frequency? Well, the shortest wavelength is actually the same thing as the largest frequency, okay? Because they're inversely related to each other, frequency and wavelength. So F is also the largest frequency, all right? Which one has the longest wavelength? Okay, well, that might be a little more difficult to see. From 10 to 5 is going to be kind of small. We don't actually have a 10 here to look at. Going to 5, what are the other highest ones? So from 3 to 2, from 5 to 3, that's smaller than this one. And from 10 to 5 is going to be smaller actually than these over here. So we're going to say that E is going to be have the longest wavelength and the shortest frequency. Anyway, the last part here asks us to put these in order of largest energy to smallest energy, and we don't care whether it's absorbed or emitted. Okay, so the largest ones are going to be the ones that involve n equals 1. So this one here and this one here. In fact, these two are exactly the same. This one starts at 1, goes up to 3. This one starts at 3, goes down to 1. So they're the same amount of energy. We're just going to put them together. A is degenerate with F. They have the same amount of energy, but they're going to be the largest energies, right? So I'm done there and there. Now, really, all we have to do to figure out which one has the next largest energy is going to be which one goes to the next smallest number. So here we have one that goes from 3 to 2. And so that one, this distance here is going to be larger than any of the distances that we'll have up in that region there. So that means that B is going to be our next largest. Okay. And then after that, we look at 3 and 3. We got the 3s here, right? This one's going from 3 to 4. This one's going from 5 to 3. Now, the difference here is they both come down to 3, or will have 3 involved. But one of them only goes to 4, and the other one goes from 5. So this one is actually a longer distance than this one. So we're going to put this one first. D would be larger than C. Okay. And then that leaves us with only E left. And so it's going to be the smallest. All right. Hope that works for you.